It's time to learn about mass. In physics, we define mass as a measure of how much matter an object has. In other words, it's a measure of the amount of substance in a particular object. Now, the key word here is substance. We don't include energy in our definition of mass because energy can be transferred from one object to another, whereas mass cannot. You might think that weight is the same thing as mass, but actually, these are two different concepts. Weight is the force of gravity acting on an object's mass. So if we change the strength of the gravitational field, then we change the object's weight, but we don't change its mass. For example, if you were to step on a scale on Earth, your weight would be around 600 newtons. But if you were to take that same scale to the Moon, where the gravitational field is weaker, your weight would be only about 100 newtons. So your mass doesn't change, but your weight does. Now we have to be careful here, because there's another way to define mass called inertial mass. This is a measure of an object's resistance to changes in its state of motion. So a person with a large inertial mass is hard to get moving, but once you get them moving, they're also hard to stop. Inertial mass is the same for all objects, regardless of where they are. So if you took that same person to the Moon, they'd still be just as hard to move as they were on Earth. Now, in most everyday situations, the difference between inertial and gravitational mass is negligible. In other words, it's so small we can't notice it. But for objects that move very fast or through very strong gravitational fields, the distinction becomes important. For example, if you were to fire a massive cannonball from Earth's surface into deep space, far away from any planets or stars, its gravitational mass would be the same as its inertial mass. But as the cannonball approached Earth's surface, the gravitational field would begin to slow it down. So even though its gravitational mass hasn't changed, its weight would decrease, and this would increase its inertial mass. Okay, now let's take a look at some key equations. The first one is the definition of weight. W is equal to mg, where W is weight, m is mass, and g is the acceleration due to gravity. So if we know the mass of an object and the acceleration due to gravity, we can calculate its weight. Next, we have Newton's second law of motion. F is equal to ma, where F is force, m is mass, and a is acceleration. This equation tells us that the force acting on an object is equal to its mass times its acceleration. So now you know what mass is and how it relates to other concepts like weight and force. Thanks for watching. See you next time.